All right, so first you're going to work on the section 7 day 1 warm-up. Go ahead and cross out the graph. You're just going to find the asymptotes, holes, and intercepts like we did yesterday. We'll add in the graphing piece today. There's no quiz over this today. Your quiz will be on Monday after we've gone over how to do the graphing piece. And you'll want to make sure that you have your graphing calculator out for that when we do notes next. Okay, so take about 5 to 8 minutes to work on this, and then unpause it when you are ready to go over it. All right, so let's go ahead and look at this. So notice that for your horizontal asymptote, I'm going to do that first. So our horizontal asymptote is going to be when you look at the degree on top and bottom. So my degree is 1 and 1. When they're the same, remember then that you turn to the leading coefficients, which will be -1/2. So then our horizontal asymptote is y equals -1/2. Okay. So this was the case where the degree is the same on top and bottom, so you take leading coefficient over leading coefficient. All right, now to get the holes and the vertical asymptotes, you need to factor everything that you can. And remember, we don't like to have a negative in front of x, so I'm going to factor out a -1. And then that leaves me with x and then +4. You can always double check. If you redistribute, you would get -x minus 4. Okay, on the bottom, we can factor out a 2. And when you do that, you should get x plus 4. Okay, so then my restrictions are x cannot equal -4. Remember that 2 without a variable doesn't give you a restriction. Now you will notice that the x plus 4's cancel, so that creates a hole at x equals -4. So this restriction here is a hole. Now there is nothing left. We've used that. There's no other restrictions left, which means that there are no vertical asymptotes. There's nothing left to be a vertical asymptote. Slant asymptotes, there's none also because there is a horizontal asymptote. So remember, if there is a horizontal asymptote, there cannot be a slant asymptote. Now let's do our intercepts. So to get the x-intercept, you take the top and set it equal to 0. So if you went back to the original and did that, and you solved, so you would add 4, so -x equals 4, so x would equal -4. That can't work because remember at -4, that is a hole. So there is not going to be an x-intercept. Because when you do set your numerator equal to 0, you get x equals -4. But remember, that was already a hole, which means we won't actually have an intercept because we would have a circle, like an open hole there. We talked about yesterday. For the y-intercept, it's best if you go back to the original. It's faster. And you're going to plug in 0 wherever you see an x, which gets rid of those terms. So then you have -4/8 for your y-intercept, which simplifies to -1/2. I told you I wanted you to write them as an ordered pair. So the x value was 0, -1/2. Always simplify your fractions. Okay, so today we'll go further and put all of this information in a graph and then use your graphing calculator to sketch in what the rest of the graph looks like. Okay. All right, so then now we're going to go on to notes. So take out your notes, section 7, day 2, open that up on OneNote, or if you have your hard copy, go ahead and take that out. And your essential question today is, how do you graph a rational function? Now, anytime if you need to pause it, go ahead and let the teacher know so that you can get it paused and be able to copy everything down and write it out. So how do you graph a rational function? Okay, so your main idea today is going to be graphing rational functions. And first, I'm going to do all of the things that we were doing before with the asymptotes and such, and the holes and the intercepts, and then we'll put it into the graph. Okay? So horizontal asymptote, we look at degrees. So my degree here is a 1, and this is x squared. So then when the degree on the bottom is bigger than the degree on top, what is that as your horizontal asymptote? Y equals 0. Don't just write 0, you have to have y equals because it's the equation of the horizontal line. Okay, for vertical asymptotes and holes, remember we have to factor and see if anything cancels. So x plus 1, what can we factor the bottom to be? So we should have x plus 4 and x minus 2. So if I do my restrictions, x can't be -4 or +2. Now remember, your restrictions make up either the holes or the vertical asymptotes or a combination of the two. Okay? Now, does anything cancel after we factor? No. So that means there are no holes. Vertical asymptotes are going to be the restrictions that are left over. So I'm going to have a vertical line at x equals -4 and a vertical line at x equals 2. And we don't put the not equal part here because these are equations of lines. We just use those numbers. Will there be any slant asymptotes? No, because there's a horizontal asymptote. Okay, to get our x-intercept, that's when we plug in 0 for the y, and we only care about the numerator equaling 0 because we already did the denominator equal to 0 with restrictions. So that would be this. So we solve. So my x-intercept is at -1. Remember, write it as an ordered pair. Okay, the y-intercept, that one is where I suggested you go back to the original. And we plug in zeros for all the x's, so that'd be 0, 0 squared is 0, 2 times 0 is 0, so those are all gone. And we have 1 divided by -8, which is -1/8. So then this is going to be 0, -1/8. Okay. So then now let's put all of this information in the graph. So y equals 0 as a horizontal asymptote is here, and let's use dashed lines for our asymptotes. So this is y equals 0. And then x equals -4. So there's one of my vertical asymptotes. And x equals 2. Another vertical asymptote. No slant asymptotes. There aren't any holes that we need to put in. Graph your x-intercept at -1, 0. Now, we know that this is an asymptote, but it's not an asymptote for every part of the problem. And so you'll kind of see when we see the graph in just a second. So -1, 0 is your x-intercept, and then 0, -1/8, about right there. Okay. All right, now let's go to your graphing calculator. And we're going to go to the y equals and clear anything that you have. And we're going to type the function, but make sure that you use parentheses as needed. So what I'm going to do is I'm going to put parentheses and then x plus 1 is my numerator. divided by parenthesis x squared plus 2x. Not deleting what I want to delete. There we go. Maybe. All right, x squared plus 2x minus 8. Close my parentheses. All right, I'm going to graph it. Okay, so notice you can kind of see we had our asymptotes correct. So in 1 to -4 there. And then, so that's an asymptote. And then at 2, that's an asymptote. And we do cross here. So these are leveling off at your y equals 0s, but it's only for these two parts of the hyperbolas here. This, it does cross that y equals 0, but it still adheres to the vertical ones. So all I want you to do is, I know on your homework it says something about graphing at least 2 points in each region. I just want you to sketch in what you have. The only points you have to plot are your x-intercepts and your y-intercepts. Otherwise, the rest of it is just a general shape. Okay, so then we're just going to go back to our picture. And so this one was shaped this way. It was an S curve in the middle. Then this one, it leveled off that way. And then this one leveled off in these two directions. And that's all you need to do for the graphing piece. Like I said, the only points that I absolutely want to see plotted, where I actually have dots, are your intercepts here. And then the rest of it can just be a general shape. Okay? So the hard part we did yesterday. Now you could look at this and if you look at your table, so hit second and then graph, they will give you some error messages. So at -4, they gave you an error, and at 2, they gave you an error. The only thing about those errors is you don't know if they're holes or if they are vertical asymptotes. Okay, unless you look at the graph or you work it out like we did. Okay, let's try the next one. Okay, so first let's start with horizontal asymptotes. So what we have here, we have x squared and x squared. So what do we do when they are the same? Well, when they're the same, we look at the coefficients in front, the leading coefficients. So we have 1 over -4. So then my horizontal asymptote is -1/4. Okay, for my vertical asymptotes and my holes, we need to factor. And I'm going to take out a -4. So that gives me what? X squared plus 4x plus 3. That way it's a lot easier to factor. So get out that -4 because we could divide it into every term. So then that gives us the stuff still on top. And then what can we factor, or how can we factor x squared plus 4x plus 3? Well, there's only 2 factors that give you 3, 1 and 3, and they both need to be positive to give you 4 in the middle. So then our restrictions are x cannot equal what? -3, -1. Now you notice though the x plus 3's cancel, so that means this -3 is a whole. So x equals -3, we're going to have a whole. Okay, so I've already used this -3 restriction, so I'm going to cross it out because you can't use it again for a vertical asymptote. So then what's left over in your restrictions is your vertical asymptote, x equals -1. And you don't put the not equals because, like I said, this is the equation of the line. Is there going to be a slant asymptote? Nope, because there's a horizontal asymptote. Our x-intercepts, then remember what we do with that. We just set the numerator equal to 0, and I recommend we go to the factored form because it's easier than that form to do. So that means we have x plus 3 and x minus 2. But we actually don't use the x plus 3 because that would give me x equals negative 3, but that was a whole. So you actually only need the x minus 2 equal to 0. So x equals positive 2 is your x-intercept. So 2, 0. Because you could set that x plus 3 equal to 0, but you get x equals negative 3, and that was already a whole, so it couldn't be an x-intercept. Then y-intercept, I would go back to the original, and you're plugging in zeros here, so that gets rid of these terms. So you have negative 6 over negative 12, which is positive 1/2. Okay. All right, I'm going to erase this work over here off my graph. So now let's graph all of this stuff. So for my horizontal asymptote, I'm at y equals negative 4, which is about right here. Or negative 1/4. Then x equals negative 1 is vertical line negative 1. No slant asymptotes. Whole, we'll plot that in just a second. And then we have 2, 0. 2, 0 is your x-intercept, and 0, 1/2 is your y. Okay, let's go type this in our calculator and see what it looks like. So we can plot in our shape. So then, like I said, for the top, all of that needs to be in parentheses. X squared plus x minus 6 divided by, parentheses, negative 4x squared minus 16x minus 12. Graph. Okay, so we did pretty good here. The graph isn't showing us where our holes are. So when we go to do that, I'll show you where we're at. But you can see it's kind of leveling off at that 1/4, that negative 1/4, and then at positive 1. So we're good there. So then our shape are just these two lines like this. We call those hyperbolas. So I'm going to do this shape and this shape, and actually these 2 points kind of go with it, and then remember it levels off. And then at x equals negative 3 in the graph, so count over 1 to negative 3, that'd be about right here where my estimate is. I'm going to erase that, and we're actually going to put an open circle there. So at 3 where this was, there's your hole. Okay. So wherever that negative 3 value is right there in that continuous curve, it actually is not there because remember x can't, that's one of our restrictions. So whatever that value is there, it doesn't work out. Okay. So that's how you graph a hole. Your graph, it's not very good at telling you that. Now, if you look at your table, it does say at negative 3, you have an error, but it doesn't tell you that that's a hole. And then this error at negative 1 is your vertical asymptote. So you can kind of look and check, and notice that the negative 1/4, y equals negative 1/4 isn't on here as a horizontal asymptote. So you would have to know that. Okay. All right, so I want you to go ahead and try example 3. So take about 5 minutes and try example 3, and you guys can work at your tables if you'd like and see if you can do the whole thing. You can do your HAs, SA, VA, holes, intercepts, and graph and get the general shape. So go ahead and pause and work on that for 5 to 8 minutes. All right, so let's look. We've got our x plus 2 here and 2x plus 6. So they're the same degree, so 1 and 1. So you look at your leading coefficients, you should get y equals 1/2. Then we're going to factor. So can't factor the top. See if we can take out a 2. Get x plus 3. So my restrictions are x cannot equal -3, so that's either got to be a whole or a vertical asymptote. Will it be a whole? No, because nothing cancels. So I can write none there. So then that means it's a vertical asymptote because that's what's left over. Remember, this 2 in front does not give you a restriction because it's not with a variable. So x equals -3 is your vertical asymptote. You should have gotten none for this slant asymptote because there is a horizontal asymptote. Your x-intercept, you're going to plug in 0 for y and only set the numerator equal to that. So when you solve, you got x equals -2. -2, 0. Y-intercept, you go back to the original, plug in zeros for the x's, so that kind of gets rid of them. So you're left with 2/6, which is 1/3 when you simplify. So you should have gotten this for your y-intercept. All right, let's graph all this. So y equals 1/2 would be here. And x equals -3 should be here. Y equals 1/2. X equals 3. -2, 0. And 0, 1/3. Just right there close to your asymptote. So then when you typed it in, you should have parentheses x plus 2 divided by parentheses 2x plus 6. Okay, so we have the hyperbolas again. You can kind of see where it's leveling off at that 1/2 and at -3. So plot those in there. And that's your answer. Looks good. All right, so work on your worksheet, the section 7 day 2 worksheet. Your quiz will be one of these types of problems where you're doing all the fill in the blanks like we did on the first day and then adding in the graphing, all of that piece. You do need to put your asymptotes, so use those dashed lines for your asymptotes, and then I'll assume that all of your solid curves or lines are part of the actual graph. Okay, you'll be able to use the rest of the time. You can check your answers on my answer key because I won't be posting them on Schoology. So if you do want to check your answers, you would need to work on them in class and check then. Then once you're done with that worksheet, make sure you do a repetition in your notes. And then you can use the rest of the time to work on any other things that you have to work on. Okay? All right, get busy.